Welcome back to the Get Willy computer lecture series, learning computer with seeing the natural sights of Indian village or natural sights. Now, the next topic is our processor speed, control unit and ALU, that is arithmetic logic unit, perform operations at incredible speed. These operations are usually synchronized with the help of a built-in electronic clock known as system clock, which emits millions of regularly spaced electric pulses per second, known as clock cycles. Which emits millions of regularly spaced electric pulses per second known as clock cycles. A processor fetches, decodes and executes instructions at proper intervals with intervals timed by a specified number of clock cycles. One cycle is the time it takes to perform one operation, such as moving a byte of data from one memory location to another. Normally, several clock cycles are required to fetch, decode, and execute a single program instruction. Shorter the clock cycle, faster the processor. Hence, the speed at which a computer executes an instruction directly depends on the computer's built-in clock speed, which is the number of pulses produced per second. We measure clock speed in megahertz (mHz) or gigahertz (GHz), where mega means 10 to the power 6 and giga means 10 to the power 9 hertz, and hertz means cycles per second. Over the years, clock speed of processors have increased steadily. Most of today's popular personal computers have clock speed is 500 megahertz or 0.5 gigahertz to 4000 megahertz or 4.0 gigahertz range. However, effort to build processors with even faster rating continues. With all other parameters being equal, a CPU operating at 3 GHz can process data thrice as fast as one operating at 1 GHz. Number of operations performed per clock cycle also affects central processing unit performance. Most CPUs perform one operation per cycle. However, the new Pentium processor uses superscalar architecture, which can execute more than one instruction in each clock cycle. It achieves this by having multiple ALUs on a single CPU chip so that it can execute two or more instructions simultaneously. Normally, we measure the processing speed of personal computers in megahertz or gigahertz, that of workstation, mini computers, and mainframe systems in MIPS, millions of instructions per second, or BIPS, billions of instructions per second, and that of supercomputers in MFLOPS, 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 millions of floating point operation per second. GFLOPS, GFLOPS, gigaflops, which refers to a billion flops, or TFlops. that is TFLOPS, teraflops, which refers to 10 to the power 12 flops. This is because personal computers generally employ a single processor chip as their CPU, central processing unit, but the other classes of computer often employ multiple processors to speed up their overall performance. Thus, a workstation, mini computer, or mainframe having a speed of 500 million instructions per second (MIPS) can execute 500 million instructions per second. Similarly, a supercomputer having a speed of 100 TFLOPS can execute 100 into 10 to the power 12, that is 10 to the power 14 floating point operations per second. We measure the speed of supercomputers in terms of FLOPS or flops, FLOPS, because supercomputer applications, which are often scientific, frequently involve floating point operation. Floating point operations deal with very small or very large numbers, which require very high precision data processing.